Hi everyone, welcome to Chemical Engineering YouTube channel. So today we'll be talking about heat transfer. You'll get to know what heat transfer is, its modes of heat transfer, factors that affect heat transfer, the applications of heat transfer in our daily lives. So without further ado, let's start the process. Heat transfer describes the flow of heat due to temperature differences and the subsequent temperature distribution and changes. How does heat transfer work? Heat transfer involves the movement of thermal energy from a region of higher temperature to a region of lower temperature. This movement occurs due to the random motion of particles in the material. The particles with higher kinetic energy transfer their energy to particles with lower kinetic energy. There are three modes of heat transfer. These are conduction, convection, and radiation. Conduction. This is the transfer of heat through direct contact between two objects. The heat is transferred from the hotter object to the colder object by the collisions between the two particles. The rate of heat transfer depends on the material properties such as thermal conductivity and thickness. So, for example, as these pictures are describing, for the first picture, one part of the rod is heated and the particles of high kinetic energy move from one side to the other side, which is the colder part of the rod, which bends the person's hand. And from the other picture too, you could see that a stick is heated by a candle and the particles with high kinetic energy moves from one part to the other part, which also heats the colder part of the stick. Mechanism. That is how conduction occurs. It occurs as kinetic energy is transferred from high energy or hot molecules to a low energy cold molecules via collisions and interactions. In solids, particularly efficient in metals, due to free electrons in non-metals, heat is conducted through lattice vibrations, which is also known as photons. Gases, less efficient due to larger intermolecular distances, occurs through molecular collisions. That is, gases are not really efficient when it comes to conduction due to the larger intermolecular distances. For example, heat from a warm hand transferring to a cooler metal surface. That was explained in the pictures before the slide. Note: conduction does not occur in liquids. So, the Fourier's law. The Fourier's law states that the negative gradient of temperature and the time rate of change of heat transfer is proportional to the area as right angles of the gradient through which the heat flows. So what they're trying to say is that the Fourier's law describes the heat flux as directly proportional to the temperature gradient, which is shown with the equation above. Convection. Convection is the transfer of heat through the movement of fluids. In liquids, the heat is transferred by the movement of the fluid particles. In gases, the heat is transferred by the movement of the gas molecules. The rate of heat transfer depends on the fluid properties such as viscosity and density. Mechanism: warmer, less dense fluid rises while cooler, denser fluid sinks, creating a circulation pattern that transfers heat. For example, warm air rising near a heater and circulating to distribute heat in a room. There are two types of convection: natural convection, which occurs due to the buoyancy-driven flow caused by the temperature differences within the fluid. The second type of convection is forced convection, which involves external forces such as fans or pumps to move the fluid and enhance heat transfer. So from the picture, we could see that as the water is boiling, warm air from the bottom of the container moves upwards whilst the cool air moves downwards. This creates a cycle, or let me say a circulation, that transfers heat. So these two pictures, that's the same pictures that's the same thing that the second picture also describes. So the Newton's law of cooling, it states that the rate of loss of heat by a body due to radiation is directly proportional to the temperature difference between the body and the surroundings, provided the temperature difference is small. So Newton's law of cooling is expressed in the equation Q is equal to HA bracket Ts minus Ca. The Ts, which stands for the surface temperature, and the Ta in the ambient temperature. The H is the heat transfer coefficient, and the K is the heat transfer rate, which can also be calculated as Q over T, which is the amount of heat transferred per unit time or per second. Radiation. This is the transfer of heat through electromagnetic waves. The heat is transferred by the emission and absorption of electromagnetic radiation. The rate of heat transfer depends on the surface properties such as emissivity and temperature. Mechanism. Heat is emitted by all objects in the form of infrared radiation and can travel through vacuum. The nature of radiation. Energy transfer depends on the surface properties and temperature of the emitting body. So as you can see from the first picture, the lit fire radiates heat to the hands, which is a transfer of heat, and the sun too radiates heat onto the earth from the second picture. So all this describes radiation as a mode of heat transfer. The Stefan Boltzmann law. It states that the total energy radiated per unit surface area of a black body per unit time is directly proportional to the fourth power of the black body absolute temperature, which is calculated with the equation shown below. Factors affecting heat transfer. Material properties. So thermal conductivity. So heat transfer occurs at a lower rate in materials of low thermal conductivity than materials of higher thermal conductivity. In other words, the lower the thermal conductivity, the lower the rate of heat transfer, and vice versa. And also specific heat. So So if a material has a low specific heat capacity, then a relatively low amount of heat is required to increase the temperature of the material. In other words, heat, heat transfer is massively affected by specific heat capacity when it's low. Density. So the increase in the bulk density will decrease the heat transfer average distance and therefore decrease the thermal conductivity. Temperature difference. Greater differences enhance the rate of heat transfer. Surface area and geometry. Large areas and specific shapes can influence how heat is transferred. Medium. Whether the medium is a solid, liquid, gas, or vacuum impact the mode and efficiency of heat transfer. Applications of heat transfer. Heat transfer is crucial in various fields. 1. Thermodynamics. Understanding heat transfer is essential for designing and optimizing thermodynamic systems such as engines, refrigerators, and heat pumps. Environmental science. Heat transfer is important in understanding climate change and the impact of global warming. It helps in modeling the transfer of heat between the Earth's surface and the atmosphere. Biomedical engineering. Heat transfer is used in the design of medical devices such as thermal therapies for cancer treatment and temperature control in medical implants. Heat transfer engineering. Heat transfer is used in the design of heat exchangers, which are used in various industries including power generation, chemical processing, and HVAC systems. For more information, these are some recommended references you can access if you want to understand anything further in this topic. Thank you very much for listening, and I'll also thank my group members, Prince and Abigail. If it wasn't for them, I won't be able to finish this work successfully. Thank you once again, and until next time, bye.